right here. So basically it's just going to stop the mouse from going the 5%. We're going to do the same for the Y. There we go. Alright, so this will be where we actually translate this into world, into a world position, basically. Screen to world point, this position, and then we'll set the position to smoothly move to that position. Alright. Now, lerp. There we go. Alright. So, this function is going to basically give you a smooth transition from this position to this. The smaller this number is, I believe it is the faster it goes. Yeah, I'm pretty sure it's either the smaller. It's either it is or it isn't. It's either the smaller the number is, the faster it moves, or the slower it moves. I can't remember right at this moment. Having a bit of a brain fart on that one. Alright, so main character, drag on the mouse follow. Then we will move the camera. Oh, what's going on? Main does not exist. Oh. Main camera is equal to main camera. There we go. Alright. There, you see? The plane follows the mouse. Alright. Things are going smoothly already. Nice little error there. So, what we're going to do is create the parallax background now. This is pretty easy. You're just going to be making a plane and applying a texture to it, essentially. Pretty basic. And then we're going to create a couple scripts to make sure that the plane will pop back up once it is out of the camera's view. So first we'll create a plane, and we'll reset the position. Now it's going to be pretty small on the in the game view, so we're going to scale it up, say 30 times. Should be good enough. Oh yeah. And yeah, let's create a prefab for it too, because we're going to be making 2 of them. So create a prefab. Go parallax plane. We'll just drag that on for right now. We'll duplicate it and move it over. Awesome. Alright, so we'll start out with the first script. And we'll call it parallax plane. There we go. Alright. So we'll rename this. Smooth. It's going very smoothly. We'll rename this Parallax Plane. There we go. Alright. So basically, to start out with this Parallax Plane, we're going to create 3 public variables. One's going to be a game object, and this will be the object that it's going to pop behind once it goes off screen. So Parallax partner, and then we will create a float that is going to be the speed, and a vector 3, which will be the movement direction. I just thought of something, but I'll fix that after. Alright, constant velocity. I'll get rid of this negative, because the negative is supposed to go in here. Be -1. Alright. So, we're going to have the parallax partner, the speed, the movement direction. And to start, pretty much all we need to do is make sure that we put something in this variable. So, if parallax partner is null, debug error, parallax partner set to null, and break so that we have to set the partner before we move on, otherwise we're going to get like 50,000 more errors in the update. Alright, so first things first, we're going to translate the object basically by its movement direction and speed. And we're going to do the time.delta time again. Just so the background is always scrolling. Once we're done that, let's create a couple variables in here. The first one, we'll create a vector 3 called object corner. And this is going to hold the position of where we should be checking is off screen. And we're going to be doing this by checking which direction we're moving and then just offsetting our current position by whatever the size of the object is, yeah, etc., etc. You'll see. Just follow along. Vector 3. Actually, we'll just do it this way. Transform.position. Much simpler. Vector 2, which is the multiplier. This is going to be just multiplying the distance from the center to the side, depending on which direction it's going. If it's going up, it'll give you a negative value. If it's going down, it'll give you a positive value. So, new vector 2, it's just 0 for right now. And we'll find the object size to figure out how far the object actually has to move. We have to do this by finding our mesh filter and accessing the mesh and finding the bounding box of the object. Now, this object, or basically what this does, it returns the size of the object if the scale is 1, 1, 1. and in here we scaled everything up by 30. So what we're going to have to do is find, basically we're just going to have to multiply the vector by the scale. So it's literally just, oh man, scale, there we go, transform dot local scale. Alright, so whatever our scale is, we multiply object size by. So the size of the bounding box is now 30 times what it was before. Now what we're going to do is we're going to figure out which way we're moving, and we're going to change the multiplier depending on it. And the easiest way to do that is, first we're going to check if the movement direction is 0 or not. Because if it is 0, we don't even have to do any of it. So if it's not equal to 0, go in. If it is, skip right over it. So multiplier.x. And we're just normalizing the movement direction, but at the same time we are finding whether or not it is negative. So basically, if movement direction is negative, it would be negative, say 1 divided by 1, because ABS gives the absolute value of the number, so whether it's negative or not, it's going to return a positive value. So if it's two positives, we get the positive. If it's a negative, we'll get a positive here, and it'll return a negative 1. And then we've basically just offset object corner by the multiplier. And the object size. And since basically the center, the object size starts at the center of the object. So we don't want to move a whole nother object size over, because you're going to have a big gap in between the objects. So we're going to divide it by -2. Alright. We're just going to do the same for the Z direction. We don't need to worry about the Y because that's not the direction that we're moving in. We'll just copy and paste. That'll save us time. Just change a couple things. Remember that multiplier is a vector 2, so there is no Z. The only reason we're doing vector 2 instead of 3 is because we don't need the extra memory. Alright. So we've moved the object, we've figured out where the object is and the size of the object, and we figured out which direction it's moving and where the corner of the object is.